Welcome back to my fifth video, fifth actually for Azure Machine Learning Studio, Microsoft Azure Machine Learning Studio. This is our fifth class for for machine learning. So in this, we in the previous, let's recap. Let's have some recap. It's been a while for me. I mean, I did yesterday. I performed all this extra minutes, so today is a completely new day. So let's do some recap here. So what we did is we have this 4, but we actually did only 2. It's the reason it's showing 2 because we also have web services for that. If you look at it, you have these 2 prediction experiments. So one is prediction and run. Let me expand that make more sense. Yeah. So we have this, we did income prediction, and then web services, we deployed a web services in income prediction with predictive experiment, and then we did automobile price prediction that we did, that was that kind of tutorial, and also like as you already know, you have this document. Let me open this document. It will take some time. So you have this document where you can view this tutorials for machine learning, which you can perform your machine learning actually. Here I'm not performing, actually there is another tutorial what I wanted to do, but it's not running for me, probably because my internet is slow or the data is too large. It's all about data, right? So the data might be something. So we have done this, right? We have predicted a price and we clean the data. Remember, we clean the data. Most of this, if you are performing any prediction, I would assume that you have to clean the data. Most of the time it will be cleaning the data or scrubbing the data, or whatever. It's up to you. Scrubbing in sense, let's say, let's assume you have uppercase in between. Let's say let's take this a name which has, let's say, you have this module, but is O is uppercase, and you don't want this O as uppercase, so you want that data scrubbing, right? So that is something, again, that's a cleaning of data, but that's not possible with this. You want to use, probably you want to use the SQL query where you already have that SQL. Remember, that will show up only when I open experiments. Here I cannot open. I'll show you actually. So that's data scrubbing. So you can also do data scrubbing that we didn't discuss actually. So so we performed this linear regression method algorithm, linear regression, that was we performed, and we actually split the data with 0.75, and we didn't put any seed, random seed. We just put it default level, and we performed this predicted value. So this is already there, and we got this result, this graph, and we evaluated this. We evaluated the model, and we got this. There is one more actually. I wanted to show you this tutorial, but unfortunately it's not working. Too bad. Too bad from my side. Actually, not that it's not working. It's working, but it's taking too long time. It's showing as like 79 KB of data, but for running that 79 KB, it's like taking more than 5 minutes or 10 minutes, I don't know. It was like for 5 minutes it was running, so you cannot waste 5 minutes, right? Or probably there is some data mismatch with that. So probably you can try this tutorial. You have this document, right? We will perform another tutorial. They are using this R script. Probably we'll not use that one, but let's see how we can do that one. So yeah, this was the tutorial. Actually wanted to show you how how we can use an algorithm. So here we use a lot of things here. You see here, we use this split data, of course, and then this is common. Alright, here you used edit metadata. You want to edit metadata because the data you want to put what the columns. So metadata, right? So what is metadata? Data of data. So data of data is like columns, the space, column space or something. You want to edit those, so that's the reason you're using it. So this model, then you're training this model into a score model and then you're evaluating it. So see, this is a really complex process. Here you have 2R script, and you're running this, normalizing the data and training it. You're training two models here and in evaluating and checking the results. Pretty complex scenario this is. But nevertheless, we will what we'll do is this is for deploying this web services. We all do all that, right? Since this German credit card is actually not working, so okay. So what we'll do today is guess what we'll do here, we'll take some of the samples. So this is for your data sets. So what are the data sets and what are the so what we'll do here, we will try to see an example what is there already there in this and close this one. So you have this, so not to worry. But if you have any questions, you can reach out to me, so that's not an issue. So here what we'll do here is, we already have some of the data sets. As I told you, go to this experiment section. You have this project where you see here we have imported 2 projects, right? We have this income prediction with income predictive. That's web services when we deploy it, because the flowchart actually completely changes. So that's the reason you have this, that prediction is completely different. And we trained 2 models, this income prediction, and see, it don't have to be income, it don't have to be price, it can be any column which you want to predict. Okay, that's how it was. I did as a tutorial point of view, but it don't have to be just price, it don't have to be just income. It could be age, it could be model, it could be, if you are taking automobile, right, it could be make, it could be engine size, engine make, you can predict almost anything. And it's just the amount of algorithms you have, you can do as much experiment as possible. I mean, you don't have to stick to only linear regression. You've seen, right, lot of methods. So I'll show you once again so that you will have clear understanding. So we also have done this transformations. Transformations are very important. So this transformations is more of a ETL perspective actually, but you have to use in machine learning too. That's pretty interesting because this is somehow related to my ETL, because I'm an ETL tester. Although I didn't use Informatica and didn't use this, that's like in Informatica you have this maplets. It's kind of maplets. This is this flowchart, right? The way we are using this flowchart, that's called maplets in Informatica. So pretty interesting that we use similar process in this too. So then you run that experiment. Okay, so that's how we do. So let's do. So today's class, what we'll do here is, that was pretty easy. If we go back, we did automobile prediction, right? Let's go back and see a little bit of so if you have not understood, you can have some. So we took a raw data. So this has raw data which you can visualize this data, and as I told you, you don't have to stick to price. I have done price for the tutorial point of view. You won't have to do that. You can use any of this prediction. So this is prediction. How you prediction? You can predict horsepower. You can predict so this is interesting. You can predict also make, but the problem here is the make is in string feature. Now you want to, so this is a string. This is not something which is see, this becomes a little complex here. Price is a numerical feature, and if you want to predict things like string feature, and that's a different story altogether. Now although you can do that thing, that's just, you can still do that, but it's a little bit a different thing, different process to do that. So what we did is we predicted price, and we've performed an operation and cleaned that missing price. We have removed the entire row, and then what we did is we selected the columns which I required. Here, I mean, I don't need this one technically. I can use all of those, but these are the important things what I need when I am doing it. So that's the reason. And then split the data, train the model using linear regression. So here you can use any kind of model, all right, not just linear model. You can use anomaly detection. You can use based on classification. We use this classification, right? One of this for in our income prediction. You can use clustering. Only one k-means clustering. You can use regression. I'm sorry, we used actually regression in the previous two. Boosted regression, boosted decision regression tree. So these are algorithms to predict. This is the model algorithm, and you train this model. This you can do one column at a time. So if you want to do second one, probably you want to use this one, and use something like this, and you have to change. So this was kind of review. And actually you can train the model and go to score model and see how this prediction. We'll visualize it again. How our the price scored labels. You have generated a new column, and it predicted a new score based on this present price, and it predicted model. So here in this scenario, right, you can use arithmetic operations to remove these 3 digits, and you don't want these 3 digits, you can also remove that, and you can do that. You have this transformation, you can do that, but we didn't do that. We made it simple a little bit. So it's kind of requirements. What do you want and how do you want to do? So that's the whole point. And then we evaluated it. So evaluation is like graph, and you got this mean, absolute error, and root. So this is very important, and this is what probably you can publish many papers on this. This is interesting thing. You can publish many papers. Probably I am also going to I'll be publishing a few of the papers on this. So this was pretty interesting actually. So this was on the regression model. Fine, this is good. This was a little bit of recap of yesterday's work. Okay. I would assume you can, based on this, you can create a lot of predictions. Okay, so it would be really good, if you know this. So let's go to new, and I will check it out. A few of this. We'll go 2 of this, and probably we'll close this out. Probably we'll also want to work on Notepad, right? Notepad, to be honest, I didn't view on this, but I'll see what we can do on that. So let's see here. I tried this one actually. Actually, we will use dataset processing and analysis, auto imports regression. So let's open that into our model, into Studio, and see what is this all about. So let's meanwhile we'll see here. It will take some time. Okay, so this experiment. Okay, so this is complex because this contains a lot of things here. Okay, let's find out. import data. You cannot visualize. That's very interesting. Now, but we'll see what is this all about. Import data, that means they are importing data from this URL. That's interesting. So you can do that too and see what, I think this gets downloaded. Let's see what's the data. Yeah, I guess I can open it in dot data format, so I can open it in Notepad. It works in Notepad actually. So this is my data, not my data, their data. Okay, so okay, great. So this is that's what they're doing this. Okay, great. So let's delete it. Okay, good. So here, what's happening is they're taking the data from a different source. So they have different source and the data format CSV. So probably they are trying to convert it to something. Okay, so let's see next. What they are doing is they are editing the metadata. Let's see what they are trying to edit the metadata. So in the column 1, so they have selected in column 1 and the data type, they are making it into categorical. So we can't visualize, right? We can't. I want to visualize. Okay, so let's do this. Guess what? I want to explain this with data, because if you will not understand this flowchart if you are not looking into data. Simple enough, right? If you want to understand this flowchart, you want to look into data, because what you are trying to do is important here. What we are trying to do here, they have put some information. That's good. We'll run this because I cannot visualize it because we have not run it. This is in the draft. So let's run it. This running will take some time. So what we are doing is we are using someone else algorithm, someone else flowchart, and trying to visualize and trying to view that method, and using this probably you can manipulate this and do your own research on this. So you can do a lot more this. Using only this, you don't have to invent new thing, you don't have to go ahead and create some new things. Using this you can do a lot more things, but first you need to understand what they are trying to do here. What they are trying to do is data set processing and analysis. So that's they are doing. So they are doing a processing analysis. Let's find out. So here yeah, we were not able to see the data. We will just it's running. It will take some time. I guess it takes like around 1 minute to run. So 1 minute or 2 minutes. So meanwhile, we'll just see here. We can visualize this and see what we are trying to do here. Okay, so this gives a little bit idea. So what's what we are trying to do here. Okay, so they are doing the data analysis. So they are predicting the data. Okay, and using a probability function evaluation, they are actually selecting particular column based on this requirement, and they are generating that linear correlations. Let's find out. Okay, so this has successfully ran. You see this check mark, green tick mark. Can we hide this? Probably, yeah, we can do that. Okay, good. I want to make some space here because we'll look into this flowchart. Okay, great. Now let's visualize it. Great, now I can visualize it. No, you can visualize because it has run. Okay, so you have 205 rows and 26 columns. That's fine. This is a raw data, so that means they have data of some data. They didn't name this column properly. They only have this column 1, column 2, column 3 and kind of things. But we don't know what exactly they are supposed to name this proper. Probably that's the reason they have this metadata. Probably we'll check it out. What's the metadata they are doing that? Okay, so this column 1, we don't know what is this. 3 1 code, some code. And column 2, we don't know. It's 1 6 4 3 numbers, some numbers. Column 3, okay, it looks like make of an automobile, fine. And column 4 is like what's it's a gas or diesel, or what is engine type, kind of engine type. Column 5, so we don't know exactly what's going on here, right? So this is just a raw data. So let's find out how. I'm sorry, let's here they have made easy for us. Let's click on this. This is a numeric feature, okay? So this is a numeric features, and this is string, of course. So these are all either numeric or string. This will be a numeric, most probably all will be numeric. And string in sense, if you have this alphabet, it's called string, and if you have numbers, then it's a numeric. That's good. Now let's see what they are trying to do in this edit metadata. So they are changing it. They have this description, that's good. This really, they've done very good job in putting that description. I have not put that in our previous class, but they have done really good job of doing this. So you can view here. So what they are doing in this metadata is they are changing the data type of column 1 to integer, making it categorical, and name it as symboling. Okay, let's visualize them. Let's try to see what they are trying to do here. So I'll show you what they have done. They are making it from numerical to categorical. So as we've seen this, okay, good. Column name they've changed to symbolizing. That's what the metadata you do, right? What do you do in metadata? Each in the columns you can change data of data. That's what you can do. So they are doing edit metadata. So that's what the metadata is. So here, if you see this, they are changed into numerical to categorical feature. So probably I'm assuming the strings remain same. We don't change the string. I guess only for one column they have done. That's right. Only for, let's find out. Yeah, column 1. If you see here, column name, and they change into column name as symboling. Okay, fine. You can have one more edit metadata. Oh yeah. So let's go to the third flow. Again, they are changing this metadata. That's fine. Here they are doing, I don't know. They didn't do in the second one. They're using a third block for column 2 and column 26. They are from integer, they're making it non-categorical. I'm sorry. The reason they are doing it, because let's find out, to clean the data, because probably there's some data mismatch, or there is no data, right? See here, they're missing data. That's good. So that's the reason they are changing this column 2 and column 26. They're changing to price. That's good. That's a good example. Actually, this is a good example of I hope you are trying to understand what I'm trying to say here. We are trying to change this metadata, man. We are doing just changing this metadata. From here this is numeric feature again, but this will be a categorical feature because they are changing to categorical. Here there's a missing data, so, and this we don't know what's column 25, they have changed into price. Column 26 they have changed into price, and this is a numerical feature. That's good. So that's what they did in this third block. Let's find out the other blocks. We have other blocks to view here. So they are cleaning this data. Let's see what they are trying to clean. So remember, we have done this cleaning work before. There was some missing values. Remember, there's a missing values. Let's visualize it again if you missed that. What they are, so see here, there's a missing values. You don't have this. So what they're trying to do in this is cleaning it, replacing with median. Either you can remove it or replace with median. Okay, so they will most probably remove it, okay, and which numeric all columns. So all columns they are cleaning it, so that's good. That's very interesting. Now they are performing this into 3 different varieties. So they are doing for so this is very interesting. So they are doing 3 models. Here you have this 3 different model. This is one model, this is second model, and this is third model. Okay, great. Right? Does it make sense? Because they are doing it 3 cleaning type, 3 different types of cleaning. One they are trying to do for custom substitution, replacing with 0, and the other one they are using is replace with median and removing that columns. That's very interesting. Third they are doing is replacing using probabilistic. Oh, that's very interesting point. So now the whole point of for me to understand this flow is they are using 3 different models, 3 different cleaning types, and trying to analyze those data, and they're not merging basically. I don't think they are merging anything, but they are trying to understand what's happening with the data after doing the cleaning of 3 different types of cleaning. One type of cleaning you have seen is substitute with the 0 values, second is with the median, third is replacing with computed probability. Right? That's very interesting. I mean, I've not seen such kind of but this is really interesting actually, because you know, the way they are trying to analyze the data by cleaning it into 3 different ways. I would not have thought of such kind of thing. Okay, that's really very interesting perspective actually to view this. So you can do that. Probably, so take it as homework. Do it as homework. Now your homework is, you know, try the 3 different. You have these models. Remember, linear regression, Bayesian linear regression, Poisson linear regression. Do this as your homework. You know, use 3 different. You know, use a similar model. Use 3 different regression, right, and evaluate the model with the same example that I have given. Do that homework. Okay, that's your homework. But this is very interesting to view. I have not, to be honest, I have not seen this before. I'm just looking right now actually. So that's the homework for you. Use 3 different models, algorithms. Sorry, what I meant is algorithm. 3 different algorithm. Use either linear regression. I've shown you, right? Clustering. We just don't go with clustering method at this point of time, unless you know what you're doing. Use linear regression. Use Bayesian linear regression, or probably you can use 3 different linear regression and assign a different value and evaluate the model and see the train the model first train the model using 3 different things, and you can use 3 different method of cleaning the data, and then train the model and get the scorecard and evaluate the model. Do that homework. Okay, so that will be a good homework for you. I mean, that should be simple. Just you are actually doing into 3 different same thing with the 3 different views of perspective and trying to see what's happening. Okay, that's good. Let's go back to here. Here one cleaning they have done, and they summarize the data. Let's visualize what they have done here. So they have summarized here. So okay, since they have cleaned that into mean, median, mode, I'm sorry, missing all values with zeros. So let's see what they have done. So this is just summarizing. I mean, it's nothing to do with. They have just added up the whole thing, and 0 max is 256, mean is 97, mean deviation, and all those things. So this is kind of you know, they are trying to find out the whole mean, median, mode, and view the results. Okay, that's fine. That's summarizing the data, computing the best. Okay, now what you are trying to do is evaluate the, so this is a different thing altogether. It's nothing to do with anything actually, just summarizing and view the data. How does the data looks like after mean, median, mode? That's fun. Okay, evaluate probability function with the mean is 12946. Very interesting. Let's find out what is this. So mean they are using 12949, standard deviation they are using 8079. I'm not exactly sure how they came up with this number, or they use some random number. This is something really very interesting. I have no idea how probably they use some random value, or maybe not. But let's visualize it. Can we visualize? Oh, this thing is something which, oh yeah, we can visualize it. So yeah, so what's happening is when they are doing this mean, median, mean and standard deviation, this is what they are getting, 12949 and the standard deviation of 8079. So this is independent actually. After cleaning the data, after cleaning the data of missing values with 0, this is what they are getting. That's very interesting perspective. So alright, let's go to that is separately completely different, nothing to do with anything. Now let's see here. Now we'll visualize, keep numeric columns only, so you will have data which is a numeric. So any string value you will not have here. That's fair enough. I don't see anything which is string value. See this make and all those things, the diesel type, engine size, all this is gone because they are selecting that particular only the numeric data. Fair enough. Here they are compute the linear correlation. They are trying to correlate and get this data. Alright, this sounds fun. But what is missing here? There's something missing. Can anyone tell me what is missing here? Alright, so there is, of course, obviously there is something missing here. I will add it up here something and show you. Probably it might work, it may not work. I have not tried that before. Okay, so let's go to the second view. They have cleaned the data using replacing with median, and we can view that result, and that result will be completely different because they have changed it with mean, median, mode. So minimum, max, mean, mean deviation, and median, and mode is 115 and range. So you've got this completely different thing because the way of cleaning the system was different, because they are cleaning it with substituting with numeric values. Here they are substituting with 0. Here they are substituting with some median values. Very interesting. And then they are keep only numeric columns. Fair enough. Compute the basic statistics. Statistics will be different here. Let's visualize it. So this will be completely different because the way they clean the data was different. So and then they compute the linear correlation. So the data here is completely different. They got price is negative. Wow, I would not imagine that, getting price is negative. Okay, that's something odd. So here this is the second flow. Let's go to the third flow. Now in the third flow they are cleaning the different value with probabilistic. Okay, and summarizing this data will be completely different. Let's visualize the data. Here it's still there is missing. Oh no, this is actually completely different. So you have that the values will be different because the way they are missing is with cleaning the data is using probabilistic, right? And they are selecting the numeric, so obviously only numeric data, and they are computing linear correlation. Let's visualize it. So all the three values will be different altogether. Now there is something missing here, right? So what's missing here is, let's find out. I will add I'm sorry, what? Not. I'll try to evaluate this model. Alright? We'll evaluate. Try to do this. I am not sure. This is an experiment. Of course, this is an experiment. I'm not sure this will work or not. I'm doing in front of you. This is my first time. So if it goes wrong, I'm sorry. Because I have not done any practice on this. So if it goes wrong, I'm really sorry. So what we're trying to do is we are evaluating it and we'll run it. Let's run this thing. So this will run this flow. It will not run everything, it just runs. I hope it runs quickly. That's really great. So this yeah, it doesn't goes everything, it only only one. We are only looking into one actually. I can do that evaluate model for all the three, but for now we are just looking into first method of see, this is like data set processing and analysis. So this in analysis they are doing into three different cleaning method. That's very interesting thing actually. So for your homework, as I told you, your homework will be do the same example, income prediction, no, price prediction for the three different. You don't have to do this three different cleaning method. Do only one cleaning method. But this thing fades. That's what I thought. Let's so we'll just first call that model. Right. I'm really sorry. I have so we cannot copy here. No. So you cannot score this model. How interesting. So you cannot evaluate this. So graph, I wanted some graph here. So so this doesn't work. This is not trained. So you can only do this for regression model, not for any other model. Okay. So let's find out. We'll train this model. Okay. So we'll train this model using, you have this option, right? We will go to our very simple thing, which is linear regression, and let's find out. Evaluate model. Alright, so training this model and evaluate this model. So we want this data set, right? So we want the data sets that will take it from here. Alright, good. So this became a little complex here actually. So we are training this for, let's say, price. Since we have price, we can only train this once. So let's run this now. This will be a pretty complicated thing. So so what I'm trying to do here is I'm trying to get a graph. Technically what I'm trying to do is I'm trying to get a graph from this. There is no graph if you see here. So what's happening is you know, I have to train a model. So they have done this good. This is good. Everything looks good. I want to get a graph for that cleaning method that they use for missing. I can do this for all three things, and I can get three different graphs. And I want to see the visualization of the graph and the root mean square. Remember, they have like sets of things, you know, 4 to 5 things, and I want to visualize that and see that how does the graph looks like, and I want to see that error as all the errors and accuracy model and all those things. So probably it might take some time. Oh, this simulation field. So I cannot take that from here, right? So we'll use this same model here. Let's run it again. I think this this also has this. See, the problem was it has NaN value. So the problem is the columns are really not good. That's a problem. So if I visualize it, let's visualize it. So the problem is the columns should be no NaN. I hope there is no NaN, right? So that really created some problem. Okay, let's visualize. I hope this should not give any problem, but if it does, then probably we cannot train this model. That's what I can say. Using linear regression, of course, doesn't work. So we'll see this. If this works for this, then it works for all the other two. So, and I'll get two different graphs for, and I won't just so what I'm looking is I'm trying to get the graph actually for this. Everything looks good. There this method of three different so this is an experiment. Of course this is an experiment. Everything is an experiment here. So in this experiment I'm trying to get a graph, and this model is still running. Finally my model has been successfully trained. Let's find out. I will visualize it. Sorry for that, because this is my first time to do this. So okay, now I got this graph. So this is the frequency. So this is what I was looking for: error and the mean absolute error and root mean squared values error, and I was trying to get this error. So what I did is I trained a model of this cleaning method. I can do that same thing for just two different things. Okay, I did only for price because, and I used this clean data set because this is nothing to do with anything, because this is a different thing altogether. Actually, it's nothing to do with this. Is pretty complex flow chart actually. Okay, so what I did is I trained a model based on their cleaning method. They used a different cleaning method for three different cleaning method, and they computed their correlation, and it's nothing to do with anything. What I did is I trained the price, not just price. I can train anything what's there here. but unfortunately these columns they, they don't have this proper columns actually. That's the worst part actually. So let's do, since the price is common, this, okay, guess what, I want to train, I can, at this point of time we can only train a numeric value. So this price is a numeric feature. It's column 23, column 27. Let's try to do column 25. We did price, that's fine. Let's go to just a column 25 and go ahead and click one, and I'll evaluate this and run this. Alright, so I can do this for string would be a little bit complex. I've not done with a string. String, that would really will take hours for me to see how the thing works for the string. Probably you might also train for the string too. That's not a big deal. But the way of algorithm that should be used is a little bit different. So let's see the graph for column number 25. I don't know what's that column because they have just put the column, they didn't put the name properly. So let's find out. So the similar functionality you can do this for this cleaning method of there. Okay, oh, that's great, we have run it successfully. That's a good news. Okay, let's visualize it. So here you have got mean absolute error 0.715244, root mean squared. So what I did, I trained a model for column number 25, and this is what I got, this graph and histogram. And guess what, it don't have to be that, you can get a different graph based on different evaluation models. So okay, and okay, so let's keep it simple. I'll not do for other two. The other two are also there to do this. Probably you can do it if you know what you're trying to do. What I try to do here is, based on this scenario, what you already have the sample, I have trained a numeric value. We did for price, we have seen, we have done for column number 25. Now let's run it, the complete model. This will take more time, but let's run this one. So this is pretty interesting actually. I've not done this before, but this will run the whole the flow chart. What is there, right? So this is similar to ETL process actually, but only thing is this differs is the way you were actually doing in machine learning. This is machine learning actually, and this is good thing is it's free. You know, Azure machine learning. I would assume after viewing my videos you would publish some papers here, okay, because I'm not sure about you, but I've learned a lot here, and I'll be probably publishing papers on this. This machine learning is pretty interesting. There's so many examples that you can perform. You can use R script, you know, you can do a lot more things. My recommendation for you is to publish a paper on this, okay. I have many papers that I have published, but in the machine learning I have not done many, but I would be doing this. So I'm expecting you also probably publish few of the papers, and there's a lot of journals that allow you to publish papers on this. So this should be pretty. So you can use your experiment and try to show the results that what you are trying to perform, and what the graph you're getting is. Okay, good. So we have successfully ran this experiment and everything looks good. We will deploy this as a web service, predictive web service, and Is this working? Okay. Yeah. So here I'm creating a predictive experiment, and this will take some time because this flowchart is pretty big. Oops, it's automatically changing, you see here. Oh, luckily we didn't got any error. Very fortunate to see that. I thought we'd be running into error again. Okay, great. Okay, and we'll deploy this. We already run, right? Run that and predictive. Okay, there is an error. That's what I thought. Okay. So we will, this is good. And I'm just waiting to run this. So it's pretty interesting to see this model of dataset processing, and I have just trained this model, and we deploy this as predictive experiments. So this will deploy as web services, and we'll see this. If I hope it works. If not, let's find out. Okay. Great. So let's test it. This is the application as we've seen this API key, and let's test it. Unfortunately, everything is 0. So okay. So that's pretty much actually. This takes a lot of time. I'm not sure if it will work or not. Okay. Okay, so this is web services where you actually have this. So we don't need this at this point of time, but this is for testing actually. And you can download this as usual. You can download it and view this, and and you can see your experiments right here. So you've got 2 experiments now. Sample 2 dataset. One is for the web services, and the other is for data for web services. I'm sorry. One is for predictive experiments, and another is for training experiment. Right. So that's pretty much and I've shown you this linear regression because now that I only know that we can use Bayesian linear method or Poisson method. There's a lot of methods here, algorithms actually. We will see this. Let's give me a second. Oh yeah, here you go. So here we have this Bayesian linear regression method. You can use Bayesian linear and do that as a homework. Okay, for the same experiment what we perform for this price, do that only for price, but for the 3 different use the same cleaning, use that same and use 3 different methods and evaluate and train that and evaluate it and get the graphs. Okay, so that's pretty much for my side. For this was for the sample 2. For what we added new thing was we use a linear regression method and tried to modify it, and we made a web services out of that. We'll do that for next experiment. Probably 2 more. Probably I also wanted to see this for the notebook, so if I have time I will do that too. So probably 2 more experiments we can view it, and rest I leave it to you, your creativity. There is a lot of so many algorithms. You can perform a lot more things by just using the samples. These are the samples. I used only samples. I have not invented something new from nowhere and put it here. You can do that too. We did that for one of those experiments. Remember, that was for tutorial point of view. But this was a completely different thing which I've used a data set from some other people who have already created, and I've trained the model from on this cleaning method of one of the cleaning method. They use 3 different cleaning methods. I don't know, they might use 10 different cleaning methods and analyze the data. You can do that. You can publish a paper on that one. So I'm expecting that to do you, so because this is pretty interesting thing. So I hope you gained some knowledge on Azure machine learning for this experiment. This is data processing and analysis. Okay, this is sample number 2, data processing analysis. So I'll end this class for this one. We'll go to the next class. In the next lecture I'll use a different data set, and it's all about data. It's all about data. And we will view that and see and train a model in that. Probably I'll use a different model. We use too much of linear regression. Probably I'll not use that anymore. Probably I'll use a different thing. So and and get the web services and deploy that web services, and so that's and deploy the web services and get the results. So that's what we want, right? So that's pretty much, and I hope you like this video, and thanks for watching.